Hello, very good evening to you. Thank you for joining once again. Hard to believe, actually, maybe I should be saying good morning. It's about 2 o'clock here in 2 o'clock a.m. in Vancouver on a Sunday morning. But here I am, following my passion. I love this course and IT overall. And you can see I'm here to present something to you. Alrighty. So we continue on to the next lecture, which is lecture number 11 in section 2. So today we'll talk about the network layer. So in the network layer, basically what we do here is we have the transport layer, which is above the network layer. The transport layer creates a TCP segment. We'll talk about TCP segments in the near future. But we have a TCP segment that comes from the transport layer, and that gets sent to the network layer. So here we have the network layer. This is the network layer right here. The TCP segment is sent from the transport layer over here to the network layer. The network layer will add its own header information in here to create what is called a network packet. And this network packet is sent to the layer below, which is the data link layer. And below the data link layer is the physical layer, right? Eventually, this information gets to the other side of the physical layer, to the data link layer, and this network packet reaches the network layer on the other side, on the receiving end. On the receiving end, the network layer is parsed so that it gets information about the TCP segment and the header information. The header information is stripped or de-encapsulated at this moment in time and then sent back to the transport layer. So let's try and summarize this information here in a slide. At the source device, the network layer is responsible for receiving segments, as we saw the TCP segments from the transport layer, right? Append the network layer information to it, right? So we saw the header from the network layer being added to the TCP segment to form a network packet, right? So we have a TCP segment coming down, forms a network packet once the header information is added. And these network packets are sent to the data link layer, right? So we saw that process in the previous slide. So the network layer header information basically includes the source and destination IP addresses, right? So this is very important to understand that the source and destination IP addresses has to be part of the network layer. So it's coming in from the header that has been added in the network layer. At this layer, the routers are a crucial component used to quite literally route information where it needs to go between networks by discovering the best path across a physical network by leveraging routing protocols. We'll talk about routing protocols at a future date. So in summary, what is important is the network layer adds IP addressing information or logical addressing information. So the network layer adds a header to the packet coming in from the upper layer, or the segment, TCP segment coming in from the upper layer, and forms a network packet. And the header includes the logical IP address of the sender as well as the IP address of the receiver. So as far as routing is concerned, the network layer is responsible for leveraging routers to route packets to their destination. Now, I just want to go over a few interesting commands that you can run on a Cisco switch that will be useful for you. Now, last time we saw in the last couple of lectures, we saw how we can set up the Cisco packet tracer, and we created a small little simple example of a PC being connected to a switch. If you're interested in Cisco packet tracer, I would highly recommend look at the other two lectures previously, where we cover the installation of the Cisco packet tracer and how to build a very simple network and how to configure a switch as well. Once you go to the switch level, you can run some very interesting commands if you want to do troubleshooting and find out what's going on the switch, right? Now, of course, you can go show run as we had before, uh, show run, which will give you the running status of the switch. We can also run show interface status. Show interface status will show you all the interfaces that are on the switch, right? And what the status is. So you can see here we have connected just one of the ports, which happens to be on port fast Ethernet 01. So it's port number 1 on the switch is fast Ethernet 0/1 is where the PC is connected to. So you can see this is connected, everything else is not connected at this moment in time. And basically the VLAN that this port belongs to, you can specify different VLANs for different ports. We'll come to that at a later date. You can see the duplex setting, which is auto in this particular case on all ports by default, and the speed is auto as well. And then you'll be able to see the speed that this port actually supports. So it's a very useful command to run quickly to find out. You can run, as I mentioned before, show running config, which gives you more detailed information. But if you want to quickly look at the interfaces and how they have, whether they have connectivity or not, what's the duplexing and so on and so forth, this is a great command to be able to run. Now, there are certain commands which are unfortunately not supported by Cisco Packet Tracer, but in a real world scenario, these are very useful commands to understand and know. So I'm going to give you some of them, which I've run in the past very successfully. I used to work with Cisco switches way back in the year 2000 and above. I got my CCNA at that time, year 2000, 2001. So, and working with Cisco switches quite a few years. So show environment alarm is an interesting one where you can see if there's any alarms on the switches. You can see show environment status, which will give you some information about the power supplies that you have on the switch and what the status is for the power supply, if the fan has any issues whatsoever, right? This is a 4506 switch, which is an older switch, but it's a very good switch and has been superseded by newer switches, but still a very good and powerful switch. It gives you, if you can run show environment temperature, this will give you temperature that the environment is undergoing and see if any issues. In here, in this particular case, there doesn't seem to be an issue basically because the chassis temperature is 40 degrees Celsius and the over temperature threshold is 75. So it's well below the 75 degrees and definitely well below the critical temperature, which is 95. So you definitely don't want to go anywhere near here, these temperatures here. So 40 degrees seems to be very safe to run your switch. The other extremely important command that you can use that I found very useful in the past is show interface counters. Now this, I'm just showing you 6 ports in here, but you can see all the ports in here when you run this command. Show interface counters I find is extremely important. You can reset these counters. You can find a command to reset these counters, but if you run this particular command, you'll be able to see how many packets have been coming in through this specific port, how many unicast packets have been coming into this port, how many octets have been coming into this port, how many multicast packets, and how many broadcasts. So if you're concerned that you're getting maybe a lot of broadcasts on a certain port, or you're getting a lot of traffic on a certain port, this will be evident over here. This is octets here. So this is the amount of bytes I should specify. And this is the amount of packets. Then there is the outbound number of octets. Of course, how many bytes have left this port, how many packets have left this port. So there'll be corresponding value depending on how big the packets are, right? How many multicast packets and how many broadcast packets have left this port. Normally, if there is an issue of any sort, if there is an attack of any sort, what you will notice is that 1 or 2 of the ports will start acting up with really huge numbers. That's how you can see that an attack is going on. Normally, you would normally want to see that the number of packets or number of octets or bytes very, very similar across multiple ports in a normal network. Unless, of course, maybe it's a server and it's really being hammered a lot, and the other ones are workstations, it could be different. But ideally, you want to see consistency across the ports. So if you see one port exceptionally having high amount of traffic, that means there may possibly be a problem in the network, and you may want to look into that. And the other one that is very, very useful, I found in my past experience here, is show interface counter errors. This is a very, very useful command that you can run. This will tell you if there's any alignment errors in the ports or in the traffic that is coming through these ports. If there's any frame check sequence errors coming in. So that means there are errors coming in. There may be issue with the wiring or something like that that could cause frame check sequence errors. So meaning to say the data is not being received properly on these ports. There is a transmit errors here, and there are receive errors over here, and there is undersize packets over here. Right? So extremely useful information to have. What you'll also see here is seeing if there are any collisions. If there is, normally on a switch, you don't want to see any collisions, right? That's why you're using a switch versus a hub. So you should not normally see a collision, but for whatever reason, if there's an issue of some sort, you may see some collisions here. But basically, you don't want to see that. You don't want to see any runs or giants, basically, either, right? So ideally, you don't want to see anything here being reported as having an issue. But this I found here, these errors have been very helpful in the past to figure out if there are any errors on any ports, right? To see if there is a problem. What you can also do is run the show log command, which will show you the log that is being collected on the switch. And of course, you can send this log to a logging server. There are commands that you can use to send it to a logging server if you have one in the environment. Highly recommend it. Here you can see these logging errors, different logging errors here. The level here is debugging here. In this particular case, just to show what's going on. You can see over here, there's some errors. There's host flapping going on between ports here, FA245 and FA247, for example. This port has been flapping. You can see there's another flap between a gigabit port and FA245. There's another flapping in here. So this could be a good sign of what is called a spanning tree protocol, meaning to say maybe there is a loop in the network and the port is flapping between two different ports for the same host address. You can see there's the same host here, and the host is being seen in two different ports, which is not normal to see. Right? So this is a great example of how you can use some very useful Cisco commands for diagnostic reasons. That's it for today. It's pretty late, as you can imagine. So we'll catch up again next time around. Thank you for joining and have a wonderful evening. Please take care. Hope to see you again. Bye-bye.